Good morning, students. So today we'll come to the last part of our chapter motion of class 9th, which is circular motion. Now, as we have already discussed earlier in the starting of this chapter, what does circular motion means? It means that a body is moving around in a circle. So circle of radius r. Now I told you that when body moves around in a circle, then there are two quantities that we can calculate. First one is distance. Now if suppose the body started moving from this point, okay, let it call point A. The body has started from point A and it is moving in anti-clockwise direction, okay, and it moves and comes back to point A. That is one complete revolution or one round, you can say. Okay, if the body is covering one round, then what is the distance? The distance will be equal to the circumference of the circle. What is the circumference of circle? 2 pi r. Okay, but if we are talking about displacement, the displacement is the shortest path between initial and final position. So if you are starting with point A, completing the round and coming back at point A, then the distance between final and initial point is 0, because both final and initial points are point A only. So distance is 0. So in that case, the displacement will be equal to 0. So if that is the case, then you can find only speed of the body. If somebody asks you to find the velocity of the body is equal to displacement upon time, and since displacement in one round is 0, that means velocity will always be equal to 0 in one round. But speed, which is distance upon time, will be given as 2 pi r, distance upon whatever time it takes to complete the revolution. Okay, so this is for one complete round. If the displacement or distance is less than one round or more than one round, then in that case both distance and displacement will have separate values. I'll take a quick example. Suppose the body starts from point A and comes to point B, which is half of the circle. It covered a semicircle. So in that case, in a semicircle, the distance will be equal to half of 2 pi r. If 2 pi r is the distance in one circle, then in half circle the distance will be equal to half of 2 pi r. So 2 pi r upon 2, which is equal to pi r, and displacement which is equal to the shortest distance between initial and final point. Now the shortest distance is not like this. The shortest distance is the straight path. So straight path is radius r plus this radius r. That means the diameter of the circle. So displacement we can write 2r. So in that case, you can find speed and velocity both. Speed will be equal to pi r upon t and velocity will be equal to 2r upon t. Okay, we'll take as example. It is a question in your NCERT. It states that an artificial satellite is moving in a circular orbit. There is a satellite which is moving in a circular orbit around the Earth. The radius is 42250 kilometers. This radius equals to 42250 kilometers. Calculate its speed if it takes 24 hours. The time is given to us. It takes 24 hours to complete one revolution. Now the question is asking speed. If instead of speed, the question would have said calculate the velocity in one revolution, then you can right away say that velocity is 0 because displacement is 0. But here it is asking for speed. So we'll use the formula speed equals to distance upon time. The distance is the circumference of the circle. So 2 pi r upon t, substituting the values, pi 3.14 and r 42250 upon t, which is 24 hours. So distance is in kilometer, time is in r. So we'll get the speed in kilometers per hour. If you solve this, you will get around 11,11055 approximately this kilometer per hour, or as the answer is given in your book, this is approximately 3.07 kilometers per second. Okay, this is the answer given in your book. So if you convert this kilometer per hour into kilometer per second, you will get this answer. Okay, I hope this was clear. I'll give you more questions on this chapter. In the entire chapter, if you have any problem, you can ask me. Thank you.